So now it's time for my third guest, my final guest, to bring us up to midday, which will have been by then 15 hours. 15 over 24 is 5/8 of the way through. Very exciting. And this is Tiago Hirth. Tiago, are you here and able to show your camera? Brilliant. So, hello. Oh, fantastic moustache. I had to comment on that very first. So it is pronounced Tiago, is it?
Yeah, but that's as good as any way to pronounce my name. Yes.
Okay. Well, you're currently you describe yourself as a mathematical adventurer. What do you mean by that?
So you know Indiana Jones, how he goes around and solves problems, and I do that just with maths.
Fantastic. That sounds like.
And I don't have a hat and I don't have a whip, but I do have rope.
Do you have rope? That's intriguing. I think I was going to chat to you for a bit, but I think actually now you've shown the rope, we're going to get straight to it and we can chat more in the middle. Yeah, please do continue with your trick.
So hello everyone. I'm happy that you noticed my mustache. You could have noticed the amazing pentamino shelf behind me, but it's a mustache.
I did notice both.
It's like that thing. My eyes are up here, not down here. Anyway, just a small joke. So hello. I'm here to talk a little bit about, well, the oldest trick in the book. Well, very likely the oldest book. You might not see this 100% because my light is not perfect, but this is a beautiful book.
Can you hold it a bit further down and closer? We've got a bit of light reflecting. If you tilt it, we might be able to. Yeah, now we can see the title. There we go.
All right. So this is the De Vidibus Quantitatis by Luca Pacioli. Well, this isn't. This is a facsimile done by Abaco Editora, an Italian publishing company linked to a museum. This is the content. So it's a huge book. I will talk about a little bit more in detail in a minute. Because I have a nice slide and PowerPoint presentation prepared, but I think we should start with some cool magic tricks from that book. And so, you know how people, I have seen that trick before. Yes, 500 years before in this book. The 21 card trick, many others, and I'm going to show two of my favorites from here. Sophie, I will need your participation. Is that okay?
That is absolutely fine. I'll turn my video back on.
Great. Sophie, how good are you at mental calculations?
Oh, that's an interesting question. Variable.
Okay. Sophie, if you want to aid yourself by using a calculator, if you want to help yourself using a calculator, you're very welcome to do so. At this point, I might mention, this is the first time I'm meeting Sophie. I could say this, but I have no idea if Sophie is a good mental calculator. If you're good with arithmetic, I'm going on a risk. I will, risk this live here on the webs for millions of people to see in the future. So Sophie,
no pressure.
So if you have a calculator, you should have it ready. If not, you can use a sheet of paper. The important part is that you think of a number. And now, because there are many mathematicians watching, I want you to make sure that this is an integer, positive integer, as big as you want, but don't make it too big because you will need to do some basic arithmetic and you will need to keep up to a running total. And so, we'll do about 3 or 4 operations. So, just choose a number you feel comfortable with.
Okay.
All right. You have a good number in your head?
I have a number.
Good. Now, what I'm going to ask you is I'm going to ask you to add half of that number to this number. So imagine you had thought of number 3, you would now add 1/2 to that number and you would have 4.5.
Okay.
Is that the case? If you have 4.5, I guess your number and the trick ends here.
No, unfortunately, okay, I did not.
Okay, great. But don't tell me the running total so far. I'm going to ask you to is it an integer?
It is not an integer.
It's not an integer. Well, I told you it's important that it's an integer. So just round up. Just make it, a whole number. So just round up and we can continue.
Okay.
Yeah. Okay. So you have this new number. and I'm going to ask you to do exactly what you did before. Add half of this new number. So imagine you had 4.5, you rounded up to 5, you would add 2.5 to this number. So in your case, I have no idea what you're going to add, but please add half of this new number to it.
Okay, I've done that.
Did you do that? Do you have a nice integer, nice whole number?
I do not.
Okay, that's no problem. Please just round up again. And now comes the hard part, okay? After you round it up comes the really, really hard part.
Right.
I'm going to ask you to tell me how many times the number 9 fits into your number, into this running total.
Okay, the number exactly or as a decimal or?
Well, how many times the number 9 fits? So if you had chosen the number 13, or if your running total is now 13, the number 9 fits 1 time into 13, and it would fit 3 times into 27 and so forth, and 3 times into 29 as well. But yeah, just tell me the exact. So the integer division by 9.
It is 85.
85.
Yeah.
Oof. Now the roles reverse, because now it is I who has to do mental calculations, and you chose a nice 3-digit number, and you see I'm already using pattern. No, that's good. Because I need to do what is that? Rounding stuff. Now I do need to do mental calculations. Well, yeah. 300. Am I off?
No, that is the correct first digit.
343.
Yes.
Nice. Cool. As you have seen, my mental prowess is more difficult in high numbers. I was hoping you would have chosen a nice small number like 13 or something, but 343 is also a good number. The fun fact is I guessed your number.
Yes, you did.
The audience goes wild. People in the chat are commenting how amazing I am, hopefully.
Or
not, or how easy it is to just, reverse everything. I will explain how this trick works. Just keep in mind, this is a 500-year-old trick. If you have innovations on it, please do show me. Let me know. I think it's a really nice, simple math trick. But unless, it's not the one where you have just, in the end, it's 3 and you just force people. It has a few nice nuances. And the other trick I would like to show you, with, you in general, Sophie, and the rest of the universe, anyone tuning in on the World Wide Web, is the ring on a chain. And for this, I have a perfectly normal chain. The fact that I have this might not be as normal. And I have a ring, or torus, or disc with the hole in it. Important part is there is a hole, and I have a ringy thing. And beside this, I will need 2 hands. Can anyone in the audience lend me a hand? No, but I have someone here at home. So please, can you give me 2 thumbs? Thumbs up, further, perfect. And this is called virtual reality. Anyway, there's a ring. The ring is on a chain. It doesn't come off. It doesn't come off the top, the bottom. Your side, my side, one side or the other. I do not know how left and right behaves on the internet. So what I'll do is I'll twist, I'll turn, and you might understand that the ring cannot come. Well, of course it can come off. This is a magic trick. So this is how the ring gets off the chain. Another cool trick with the ring on a chain, but this one isn't from 500 years ago, you might have seen, which is a ring that goes onto a chain. And if I were to drop, what do you think would happen? Well, it gets stuck. It's a magic trick. You were going to expect that, right? Another trick. I need hands again. Can you put your index fingers? Yep, perfect. And you can see it's on here. I'm going to ask you to touch index fingers together in the middle of the ring, just like that. And I hope you can see that at home. Look, it comes off perfectly. And the ring as well. And so these are the magic tricks. Thank you so much. Ta-da! Applause. Everyone in the comments going wild. Well, as you might know, magic is intended to happen live, in real life, in your hands. So hopefully you will have enjoyed this a little bit. And so a friend of mine says magic is supposed to happen after it gets dark. Well, hopefully there are some really late night owls somewhere around the world, perhaps in the United States. But since this is not only a show, this is also a math thing, I would like to go into explaining some of these things in a bit more detail. Is that good with you, Sophie?
That sounds good. We've got some comments on YouTube. Goran says, "Whoa, that's amazing." And Alison says, "Tiago, you are some sort of god." So you're about to shatter that illusion, but
all right, cool. Well, I will go over to presentation mode, which means that I will lose complete control of site, I guess, and I have not. Ooh, security alert. Uh-oh. Yep. And I will go over to the presentation, hopefully. Does this work? Can you see a presentation?
Yep.
Is it? It's not in full screen yet, is it?
Not in full screen yet.
And now it is. Yes?
Yep, cool. It is now good.
So basically, I made a small presentation called The Magic of Numbers. The book you saw previously, the Vidibus Quantitatis by Luca Pacioli, translates the Vidibus Quantitatis, translates roughly into the power of numbers. Now, since this is a magic marathon, math magic marathon, I thought it would make more sense to call it the magic of the magic of numbers. And so basically what I did, I made a selection of only the magical effects in this book and chose my two favorites, which I showed you, plus some extras because I really like to do those things on a chain with a ring. But I'll go into the book a little bit further. So the book was written by Fra Luca Bartolomeo de Pacioli di Borgo San Sepolcro, nowadays in Italy. And basically, who was this person? He was a scholar of the Franciscan order who lived somewhere between 1445, which hopefully is now the running minute count for the math marathon, and he died somewhere around 1517. Somewhere, because there are multiple dates of death, you know, dates, timekeeping, and so on. Difficult thing. I mean, we get things wrong when we are on the internet, GMT plus minus something. Back then, it was all the rage with the years. Anyway, he might have been a disciple of Piero della Francesca, who was a famous painter, and he was a close friend to Leonardo da Vinci, who we met at the Milan court of the Sforza. But of course, like people in that time, he would run around and teach at many famous universities, from Perugia to Zadar, Pisa, Florence, Aquila, and Perugia. He wrote multiple really cool books, among which is present a certain trend. First, he tried to make things accessible to a general reading public. So unlike other scholars of his time, who would mostly write in Latin, he had a big concern to translate things into Vulgate, which is a simplified Latin form, which was what common people would speak. And as you might find in my slide, there is still an artifact of Latin, which is basically from my Portuguese slide, because I translated these slides. So there's a translation, tradução in Portuguese, of the elements of Euclid from the Campanas version. He wrote the most used textbook of his time, the Summa Arithmetica, which was used 50 years since it was published, which we change manuals in Portugal at least every year. Imagine to have a textbook that lasts 50 years. It's even at that time, it was a signal of great value. He wrote one of the first popularizing books, which actually still to this date makes the golden ratio a huge deal for science communicator, which is the Divina Proporzione, the holy proportion. He wrote books on games like Griskaki, which is a treatise on chess. He also wrote the Ludo Scachorum, Ditas Kifa Noia, and of course he wrote Dividibus Quantitatis. So here's a picture of the chess treatise. You can see really nice figures. You can see his amazing handwriting. It's really hard to read. You can see the beautiful illustrations by Leonardo da Vinci in the Divina Proporzione, which are very famous. Many people reference them. And you have here the translation of the elements. Just, I really like that. But back to my focus of study, which is the Viribus Quantitatis, a book on which many books have been written. So here are some cool things that are related to Pacioli and are related to the Viribus Quantitatis. If you want to,
we're still currently seeing the streaming, your screen.
Okay, so my image is not appearing, or?
No, if you want to turn off your screen sharing, you should be able to.
It will be too complicated to turn it back on. So basically, I was showing some books, but I'm happy to show them after I finish the presentation. So anyway, the Viribus Quantitatis is basically roughly divided into 3 volumes. So the first volume is the volume that gives name to the book. On the power of numbers, and it's basically all of it is related to arithmetical and algebraic kind of problems. The second volume is called The Power of the Line, and it's mostly related to geometrical things. And the last part is called The Power of Nature, which compares things to, well, explains natural phenomena and this demystifies charlatans in an almost illuminist way. And so all of these parts, they are roughly divisible into 2 parts, one formal and one more loose. The formal part is usually using things from well-known textbook, like the elements, and transforming them into some sort of magic trick or puzzle. And so we find very, very famous problems like, or magic tricks in this case, how to find something hidden among 3 people, and then you use this equation, this equality. But then you also have always the loose part. So there's the formal part, and then you have a loose part in which you would treat problems that at that time did not have a formal structure, like the Josephus problem, or like in the part of the lines, the problems with center of mass, and I can show you a nice toy in that regard after I finish if you remind me, after I finish the slides, or something like squaring the square, which Pacioli mentions is impossible. At least I think he believed it to be impossible unless you were speaking about square frames. But of course, as we know, in the 20th century, there were many solutions, and we're still finding beautiful solutions nowadays about how we can square squares with squares. And in the last part, of course, the more formal part explains how, according to natural philosophers, certain things are possible. And in the more loose part, you will get a lot of enigmas and jokes. And well, if you understand some jokes, the 2 citations, the first one is one of my favorite jokes in Latin. Then again, I do not know that many jokes in Latin. Anyway, back to my tricks. I hope you still remember. This is a lot of information, and I'm kind of throwing it all out there. You can then later rewatch this and point out all the mistakes and write an errata in the chat, which I will be looking forward to. But back to our definition from previously. So, as you might remember, you thought of a number which was 343, and I asked you to perform some operations. And then I was able to guess that number. So basically, it is roughly based on this equality. So you chose a number n, which is not straight. It's not straightly divisible by 4, but there will be a remainder. So that's 4 cubed plus 8, and the remainder is either 0, 1, 2, or 3. And this is basically what I forced you to do. Now, this is a little bit alchemical. It's and the way Pacioli describes it is, you shall do this, and then you shall do that, and it's a lot almost a recipe. This is the recipe boiled down and put into modern notation. So basically, what I'm trying to probe for is the rest. When I ask you to round up, I'm actually taking notice that I have a running total for the R myself. So either you have a remainder of 0, 1, 2, or 3. And so every time you round up, I'm mentally trying to keep track of that. And in the end, basically, all I need to know is how many nines fit into it, because that's what I'm going to multiply by 4. And 4 times 85 was more than I expected to do this morning. Anyway, here are the basic instructions that I basically, all the tricks I did, you just do exactly as I did them, and you will be able to perform them perfectly. The important part is then to make a trick out of it. So the instructions are: think of a number n, which you did, 343. My example is 3, which is much easier. Then the second part is add half of that number, which is n divided by 2, which I will not even try to attempt doing now while I'm trying to focus on other things. 343 divided by 2. You did that. You had to round
171 and a half. Yeah.
Beautiful. And then what I'm doing, which is much easier than dividing 343, is all I'm doing is I'm basically adding 1, because you had to round up, and that's all I need to take care of. Then you're going to add half of this new number and round that up again. And again, I'm just keeping track. Did you round up? Sure. If you round it up, cool. Then I'm adding 2. So I would have 1 plus 2, which is 3. And finally, you're going to tell me how often the number 9 fits into the result, which was 85. So all I have to do is 4 times 85 and add my r to it, so which is the rest was 3. So whatever I had to do was 340 plus 3, and that gave me your original number. And my example here is with the number 13, because many people chose the number 13, and sometimes this makes for a good trick because I predict things in the future. Anyway, hopefully people have gotten the gist of this. How much time do I still have?
You have another 8 minutes.
Ooh, 8 minutes. Okay. Then I will just skip back to stop screen sharing, and I will try to explain slowly how to do the ring on a chain, which is, I will need my hands again, and which is, we place the ring on the chain, on the thumbs up, and the ring is on here. And what I do is I will release the ring from here by simply releasing it from there. It falls off. Now, of course, I need to do this in such a way that obscures the whole movement. So what I do is, what I'm doing now is an unloop. So basically, it's not on here. You might see that this part fits straight over here, and you might see that if I release, everything falls off. Hopefully, you are seeing this well. But right now, I keep this in place. Now, the next part I'm going to do is I'm going to thread the chain back on, so there is an illusion that the chain never actually came off. And what I do is I put it back on here. Now, when I release everything, the ring is not on there anymore, as you might have seen previously. But the chain is back looped around. So I try to obscure this by putting my hand in front of here. But for the sake of clarity, I shall not this time. And now you see that the ring comes up. Ta-da! Yeah, time for Q&A or to show you the cool books that you didn't see previously. So this is a beautiful book by Furio Honcel and Giorgio Tommaso Bagni on the Dividus Quantitatis. There's another beautiful book if you are into magic that only discusses the magic of Luca Pacioli. And here you can see the same ring trick, but instead of a ring with a key. And this is actually the first place that this trick appears. There are variants of this trick which also appear here, which I think I have never read them elsewhere. And this beautiful book is written by it's called Matemagia, I giochi di prestigio di Luca Pacioli, and it's written by Vanni Bossi. Beautiful book. If, however, you do not read Italian, you can just Google the book and you will find, well, it could be updated version of my master's thesis, which basically was on this book, and it has the English description and discussion of many of these tricks. And yeah, well, anyway, my point was still on the Dividus Quantitatis. It's a humongous and very beautiful treatise. It has a very big and rich story. And many of the things we do in math communications nowadays, or many things that magicians do, or many things that teachers use in classes, can be found here for the first time. And of course, the way we treat things, the way we work with these things has changed over time. but the juice, the gist of it, the content is amazingly beautiful, and I encourage you very, very dearly to take a look into it. And of course, it's not only magic, but I guess this will be the topic for another 24-hour magic session, because there are amazing puzzles, there's amazing art in it, and I will finish here.
Brilliant. Well, thank you very much for joining us, Tiago. If people want to follow you on Twitter or something, is there a name they can look up?
I do not have Twitter, but I'm happy to share my slides again and to give you my email. And if you're interested in anything of the things I've mentioned, I will be very, very much looking forward to hearing from you. The broad internet in general, only nice things or corrections, which are nice as long as they're posted in a nice way. And this quickly through the slides. Can you see the slides again?
We can indeed.
And as you see, quick stop over here. You know the 21 card trick? Well, it's in the book, just with coins and in binary. But you can do it with cards as well. Some illusions, some puzzles, and more puzzles. And what I wanted to share was my contact, which is down here. Just send me an email if you want to share more insight into anything I did, correct me, or just talk about these topics. I will be very happy to get an email from you.
Well, thank you very much, Tiago. And yeah, thank you for joining us.